Today we're going to look at the absolute value function. Let's start with the warm-up. How does the following function shift? We have y equals x plus 3 squared minus 6. So you should know the squared indicates this is a quadratic, a U-shaped graph or a parabola. And we've looked at, we spent a few days looking at how it shifts if it's inside the parentheses versus outside. So we know if it's inside of the parentheses or it's left or right. And plus 3 indicates that this is going to go left 3 units, and the minus 6 means it's going to go down 6 units. Write the equation of the quadratic that shifts 7 units right and 3 units up. So we're going to write y equals parentheses. If it's left or right, it's inside the parentheses, and right is x minus. We need a squared for the quadratic, and it's up 4, so plus 4. Today we're going to look at another function and also look at how it shifts. Today is the absolute value. So let's start with the parent function, the graph. And let's graph. So I'm just going to pick some points here to graph. Let's say x is -2, -1, 0, 1, and 2. And let's plug into this function y equals the absolute value of x. The first one is y equals the absolute value of -2, which means what's the distance of -2 from 0? Well, that's 2 away. What's the absolute value of -1? That is 1. It's 1 unit away from 0. The absolute value of 0 is 0. The absolute value of 1 is 1. 2 is 2, and so on. Oops. So let's graph this. We have -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. And if I were to sketch that, we can see that it's a V-shaped graph. If I asked you what is the vertex is where it changes direction, and that would be at 0, 0. Okay, so today we're going to look at how it shifts, this V-shaped graph. On your graphing calculator, it says, open a new graph page and type in to the f1 of x, the absolute value of x. To do that, we're going to find this button right here, so I'll show you where that is. It's to the left of the book button under delete, and there's absolute value. So let's add a graph and do that. Okay, so y equals the absolute value of x, and we should get that graph, that V-shaped graph with the vertex at 0, 0, just like we graph by hand. It says make and write down your predictions
Could you call 6102
on how the following function will be shifted. So let's see. If the absolute value is like parentheses, the plus 2 should be up 2. So let's check our prediction. I'm going to hit tab and do absolute value of x. And then we'll do plus 2. And it does shift up 2. Let's take a look at the next one. Absolute value of x minus 3. So again, if the absolute value is like parentheses, this would shift to the right 3. Let's try that in our calculator. I'll hit tab and go up. And I'll edit this one and just do a minus 3 on the inside. And it does go to the right 3. How about the next one? Plus 1 minus 2, so I'm going to guess left 1, down 2. And again, we'll type this in. I'll hit tab and go up. Okay, so the equation was plus 1. And down 2, minus 2. And it does go left 1 and down 2. So now let's calculate the vertex. We know that the absolute value of x, the vertex was at 0, 0. And if we know that this shifts right 2, I'm sorry, this is left 2, not right 2, the vertex will be at -2, 0. If this shifts left 3, down 4, be -3, -4. This one shifts right 1, up 2, so the vertex would be 1, 2. And this one shifts right 4, up 3, so 4, 3. So if we forget any of these rules, we can type them in our calculator. In general, the vertex will be the opposite of h. And the k value stays the same. So again, if you look at our examples, it's the opposite of what's inside the parentheses or the absolute value sign, but on the outside the k value stays the same. Okay, so now let's look at dilations. In your calculator, type in the following and see what you notice. So let's get rid of this guy right here. Okay, so I'm going to type in the first one, which is 1.5x, absolute value of x. Okay, so this one is narrower. Let's see the next one, 2x. So tab. That one again is narrower. Let's try the next one, 3x. And again, that one's narrower. And let's try 4x. See what happens. That one is also narrower. So these graphs are skinnier or narrower than the original graph. Now let's try graphing these four functions, these decimals, and see what happens to our graph. So the first one is uh, 0.5x. Okay, that one's wider. The next one is 0.25x. Oops. Okay, so again, that one's wider. 0.75x. Okay, that one's wider. So all of these are wider than the original. So in general, oh, and then what happens if there's a negative in front? So let's take a look at if we put a negative in front. First one's -2. It flips. Let's do the next one, -0.25. Again, that one's flipped as well. So when it's there's a negative, it flips. It's upside down. Okay, so let's summarize. Restart workspace here. So what happens when A is negative? It flips over, it's upside down. When A is bigger than 1, then it was narrower or skinnier than the original. And when A is a number smaller than 1, like 0.25, it was fatter or wider than the original. So now let's look at how we'd actually graph that. Drawing the A value. The A value is the number in front, so here the A value is 1. It's kind of like drawing the slope. So first of all, what's the vertex? This shifts left 2, down 3, so -2, 3. -3, -2, -3 is right here. And then the A value is like the slope. So the slope is 1. It means from the vertex, we're going to go up 1 over 1, up 1 over 1 in each direction. So up 1 over 1, up 1 over 1. And if we do this one right here, the vertex, this is a right 1. Oops. And then it's up or down 0, so our vertex is 1, 0. The slope is -2. It means from our vertex we're going to go down 2 over 1 in each direction. And so we can see that negative flips it, and it makes it a little bit skinnier than the original because the slope is 2. So you're going to be practicing all of these ideas, a lot of review, but you have this new part that's the slope, and then this new function, absolute value.